Good morning, student. Today we will begin with lecture number 32, unit 3, elastic constant, topic numerical, shear stress and punching shear. We will solve 4 numericals today. Important formula. First one, shearing area of plate is equal to circumference of shearing area into thickness of plate. Number 2, factor of safety is equal to ultimate shear stress divided by permissible shear stress. First numerical, a circular hole (25 mm) diameter is to be punched in a mild steel plate 3 mm thick. If the shearing stress developed in the metal is 200 MPa, find the required force to punch the hole. Given diameter D 25 mm, thickness T 3 mm. Shear stress is equal to Q is equal to 200 MPa is equal to 200 Newton per mm square. We know shear force P is equal to shear stress Q into shearing area. Q into A, Q 200 into pi into D into T is equal to 200 into pi into 25 into 3. P is equal to 47.12 into 10 raised to 3 Newton, which is equal to 47.112 kilonewton. Numerical 2. Calculate the force required to punch a hole of 30 mm diameter in a metal plate of 20 mm thick. The permissible shear stress in the material and corresponding factor of safety is 400 MPa and 3 respectively. Solution: diameter D of hole is 30 mm, thickness of metal plate 20 mm, Q is equal to permissible shear stress is equal to 400 MPa is equal to 400 Newton per mm square. Factor of safety 3. Note that while punching a hole through a mild steel plate, the material of the plate along the circumference will be sheared off. We know that shearing area of plate A is equal to circumference of hole into thickness of plate. A is equal to pi D into T is equal to pi into 30, that is the diameter, into 20, thickness, is equal to 1884.95 mm square. Factor of safety is equal to ultimate shear stress divided by permissible shear stress. Now ultimate shear stress is equal to factor of safety into permissible shear stress. Factor of safety is 3, permissible shear stress 400, which comes to be 1200 Newton per mm square. So here we have found ultimate shear stress. Now we have to find out the force. We know what force? Force is nothing but stress into area. Stress into area. Let P be the force required to punch the hole. We know that ultimate shear stress, that is stress, is equal to force divided by area. Here force required to punch hole divided by shearing area. Ultimate shear stress is 1200 is equal to P divided by area. 1200 is equal to P divided by 1884.95. P is equal to 1200 into 1884.95 is equal to 2261940 Newton. Numerical 3. In all the numerical here, you just have to know the formula and you have to substitute the value. Comparatively easy, not much of analysis, but substitution of value, for which you need to know all the formula. Question number 3. The ultimate shear stress for mild steel is 300 Newton per mm square. Find the force required to punch a hole of 16 mm diameter in a plate of 20 mm thickness. Calculate the compressive force developed. Somewhat of the question number 2, but some changes. This is just an example of figure for your understanding. Now this is a place. This is a plate of thickness T, the hole which we have to punch, diameter D, and the shear force punch the hole. So one single force. Now into the hole it has to be a the punch. Let's see the other figure. Now this is going to be something in your workshop. We have a plate, again diameter 16 mm, plate thickness 20 mm, the hole, and we have a punch shown in blue color on which a force F is applied. This is going to be a compressive force. Let's solve the numerical. Given Q 300 Newton per mm square, diameter D 16 mm, thickness T 20 mm. Note that magnitude of compressive force and shear force is same, but are affected by them is different. To find the force required to punch, that is shear force F, we know stress is equal to force divided by area. Here shear stress is Q, shear force F divided by the affected area A. F is equal to Q into E is equal to Q into pi dt. Pi d is the circumference into T thickness. So F is equal to 300 into pi into D is 16 into T 20, which is 301,592.89 Newton. Now we have find the shear force. We have to find the compressive force. Okay. Now note that the magnitude of compressive force and shear force is same, but area affected by them is different. Therefore, Compressive force is equal to shear force. Compressive force is equal to 301592.89. यहाँ पे ये देखना चाहिए जब कॉम्प्रेसिव फोर्स कहते हैं तो प्लेट को परपेंडिकुलर होता है। तो हम जब डायग्राम में पंच देखे हैं तो पंच से जब करते हैं तो पंच प्लेट को परपेंडिकुलर होता है, तब ये क्या होता है, कॉम्प्रेसिव फोर्स। लेकिन यहाँ पे हमें सारा फॉर्मूला, सारा स्टडी शेयर में है। शेयर कैसा होता है, होल को जो सर्कमफ्रेंस है होल का उसको पैरेलल होता है। तो ये कॉम्प्रेसिव फोर्स यहाँ पे जब पंच होता है, होल होता है, तो शेयर फोर्स के इक्वल आ जाता है। यानी ये कॉम्प्रेसिव फोर्स यूँ समझ सकते हैं कि अफेक्ट बाद में, यही शेयर फोर्स बाद में जब सर्कमफ्रेंस के साइड पे होता है तो इसे हम शेयर फोर्स कहते हैं। तो मैग्नीट्यूड सेम है लेकिन एरिया ऑफ इफेक्ट होना अलग अलग है। एक्सक्यूज मी। क्वेश्चन नंबर 4। A punch of 12 mm diameter is used to punch a hole in a plate of 20 mm thickness. The ultimate punching shear stress in the plate material is 300 Newton per mm square. Determine the force required for punching and compressive stress in the punch. Somewhat same problem. Given D is equal to 12 mm, thickness T 20 mm, ultimate shear stress 300 mm, Newton mm square. I'm sorry. Ultimate shear stress 300 Newton per mm square. To find the force required for punching, that is P. Now we have studied punching force here is a compressive force, and shearing force. That is compressive force and shearing force here are same, but the area is effect. मैं फिर से बताना चाहता हूँ, जब पंच हम मेटल प्लेट के ऊपर रखते हैं और जब हैमर से स्ट्राइक करते हैं तो पंच का जो टिप होता है वो प्लेट के ऊपर होता है। तो यहाँ पे जब कॉम्प्रेसिव फोर्स एक्ट होता है तो वो परपेंडिकुलर टू प्लेट होता है, या फोर्स इज एक्टिंग परपेंडिकुलर टू द प्लेट, तो ये हो गया कॉम्प्रेसिव फोर्स। लेकिन जब होल गिरता है मेटल प्लेट में तो ये सर्कमफ्रेंस पे होल बनता है और ये होता है सर्कमफ्रेंस के थ्रू एक्ट होता है सेम फोर्स, तो इसे हम शेयरिंग कहते हैं, इसे हम शेयरिंग फोर्स कहते हैं। इसलिए बार बार नोट दिया गया है कि हर compressive force is equal to shearing force. compressive force shearing force है, लेकिन जो एरिया अफेक्ट करती है वो अलग अलग है, वो अलग अलग है। शेयरिंग एरिया इज इक्वल टू पाई इंटू डी इंटू टी। पाई इंटू डी इंटू टी, यानी पाई डी क्या हुआ, होल का सर्कमफ्रेंस और उसका थिकनेस से मल्टीप्लाई किया तो होल के अंदर की बाजू की जो एरिया है, जो शेयरिंग एरिया, वो आपको मिलेगी। कितना है, पाई इंटू 12 इंटू 20, 753.982 mm स्क्वायर। force P required to punch a hole is equal to ultimate shear stress into shearing area. P is equal to 300 into 753.982. P is equal to 226.194 kilonewton. Now to find compressive stress. Compressive stress sigma C is equal to force divided by area. Force divided by area. Sigma C is equal to 226.194 into 10 raised to 3 divided by 753.98. Sigma C is equal to 1999.994 Newton per mm square. I hope student you understood it. Thank you.